So the next step in this process would be getting the player to move. And getting the player to move would require a script. So this is where we move on to scripting in Godot. The way scripts work in Godot is that any single node in the tree can have a script attached to it. No matter what type of node it is, you can attach a script to it and add functionality to it. So if our player scene is closed, there's multiple ways we can open it. We can either click this and it will open it, or we can go into our file system and navigate to game objects, player scene, and we can open it like that as well. Now, to add a script to any object, all we have to do is go to the object, right-click it, and you'll see Attach Script. And for the first couple videos of this series, I'm actually going to be using GDScript to introduce all of you to the language. It's a really great way of understanding the integrated language just so that you know it exists and you know what Godot is built upon. But then if you still don't like it, and you still don't feel comfortable with it, you can always shift over to using C# support. It inherits from the character body, because remember, that's the type of node that we made the root node. What we're going to do is we're just going to go object empty. We don't want built-in script. Built-in script makes it so that the script is a part of the scene file and is not a separate file. I almost never use this. I like to always export my scripts so I know where to find them. So now that we have this, we are going to go to path, and I like to group my scripts alongside the nodes and their functionality. I know that in Unity, it's usually a practice of having scripts be completely separate from the objects and just separating things, but I personally like to put it alongside the object if it is the main script for that object. And we are going to create. And what you'll see is at the top, you'll notice it actually tabbed between it automatically when creating a script. So automatically tab to this view to script view. And right here what you'll notice is we have a script which extends the character body 2D. First, I'm just going to show you how I would go about implementing this. So the first thing we need to do with our character body is we actually need a way of getting input from the player. So before we even do the script, we actually need to set up input in the input map. Now, the input map in Godot is pretty flexible and pretty awesome. You can access it by just going to Project and Project Settings. And right here, the next tab, you'll see Input Map. It looks to be empty, but over here, if you click Show Built-in Actions, this will show you all of the input actions that are built into Godot. And if you don't want to use any of these, you could just hide them. We want to create a new action. So let's see how it says add new action right here? Let's click this and let's add an action called move_right. And actions are nice because they allow you to check if a certain input is being pressed down via this action key, which is really helpful. So we can actually hook up this action key to an actual real input action by clicking add event over here. And we can go through this list and figure out the event, or you can go up here to filter by event, and what it will do is it'll listen to whatever button you're pressing. So in this case, we're going to go D, and we'll hook that up. But let's say somebody wants to play with arrow keys, and we want that to also be move right. Well, no problem. We just click add event again, and we just click the right key. And now we have both D and right hooked up to those directions. Now that you know how to create input maps, I want you on your own to go through and create move left, move up, and move down, just to solidify that you understand the concept of creating input maps. All right, now that we have set up our input maps, the next step is to actually create some sort of movement for the player. So let's close this, and let's actually dive into GDScript and how to get this to work. So we're going to create a variable. So this is how you create variables. You do the keyword var, and then you type in the name of the variable. In this case, we're going to do input velocity. And then it's always good practice to type your variables. GDScript is flexible in the sense that you don't have to type all your variables, but I would suggest that you type everything to just get into the practice of how to correctly make sure every variable has a specific type of data and can't be more than one type of data. It's usually a good practice in general, but the flexibility does come in handy if you have, for example, a variable that needs to hold some sort of object, but you don't have a base object class. So that variable can then be set to any object, which is kind of nice. But in this case, we have a variable called input velocity, and we're actually going to type it with the vector 2 type. So now that we have this vector2, we're going to, by default, set this equal to vector2.0. And that is how you define a variable in GDScript. It's pretty simple for the most part. So now what we need to do is actually use this input velocity, and we need to get the player's input. What we want to do is we want to create an input map where we can get the strength of the input values that we're holding down, and we subtract the -1 from the positive. So another way of explaining that is, let's say we're holding down the right and left keys together. The two should cancel each other out to 0. If we're holding down the right key, it should be 1, and if we're holding down the left key, it should be -1. So we need to call some sort of process function that runs every frame. But before we can do that, we need to figure out how to define functions. The syntax for defining functions is func, then the function's name, named function, then these parentheses, and then a colon. And in these parentheses is where you can actually pass a variable for the function to use. For example, I could pass a variable called number of type int. And then if you want to pass multiple, you just separate them by commas. So I could pass a string of type string, right? And that's how you pass the things in the function. Now, a fun little tip is if you want to just define a function, but you don't want to actually set it up yet, you can actually just use the pass keyword. So that's how you declare a function. So how do we get our process function? Well, we can use _process. So this is the built-in process function, and what this will do is run every frame. What we can do is actually get our input velocity via this. So we can do input velocity dot x. We'll start with the x-axis. And this is how you can get input strength of a button. You go input. That's an object that you can reference that handles input. You go input.get action strength. And we're going to go move right. And you'll notice the autocomplete shows all those actions we set up. So now we have move right. So we're going to subtract that by move left. Now we do the exact same thing with the y. Now that we have our inputs mapped to our input velocity, we need some way of reading that variable to be able to determine if it's correct or not. Well, Godot has a really useful feature called the print function. And this lets you print a variable or strings or anything so you can easily determine what a value is. So we're actually going to create a string here. And in this string, we're going to put input velocity, colon, space. And then we can separate with a comma the different things that you have printed out in line. So then we can do input velocity. So this is one way to write this. You could also do plus input velocity, but the issue here is you're trying to add a string with a vector2. So you can convert the vector2 into a string. So type conversion, all you have to do is put the variable type, and then in parentheses, put the variable you want to convert. So I could, for example, do a variable input velocity as string. We'll type that to a string. And we could do str input velocity. And then we could replace this str with this. So now that we have this, we can run. And you'll notice right here, input velocity, if we put right, we get 1, 0. If we go left, we go -1, 0. If we do both, we get 0, 0. So they cancel each other out. And same with the y-axis. So that is how you set up input mapping and how you can display it as a print value. So we're actually going to remove these lines now that we know that we've done that correctly. And now we need to take this input velocity and actually cause it to move the player. So we're going to create a new variable called speed. And this is going to be an int value. And let's for now just set it to 100. And what we will do is we now need to actually start figuring out how to move the player via a physics process. So now this is where we need to use the physics process function, because movement is related to physics, and so we want the player to move via a physics process frame step rather than a process frame step. So what we're going to do is we're actually going to set the velocity built-in variable of the character 2D. If I type velocity, you'll notice it actually becomes this little light blue. And that means we're using a variable that it already exists that is part of the extended class. So what we can do is set our velocity equal to the input velocity times our speed. And then all we need to do is call a function called move and slide. So we save this and we run our scene. And now let's try moving. You'll notice we actually move the rocket around in a kind of weird way. We're moving it up, down, left, and right, which doesn't really work for rocket movement, which we will actually develop on now. We're going to now create a thrusting system. So now, to squash a couple of concerns that you might have, you might be asking, if you're a seasoned Unity developer, why aren't we multiplying velocity times delta so that way it is frame dependent? Well, the move and slide function actually automatically moves the player, and it takes its velocity variable and already multiplies by delta. So keep that in mind. This is something that I personally am not a huge fan of. I really think that you should be able to put times this by delta, and you should do it manually because it makes it more clear as to what you're doing. But just keep in mind, for the velocity and move slide of specifically character body 2Ds, it already multiplies by delta. So just keep that in mind. All right, now that we have this set up, let's think about how we actually would go about creating some sort of rocket movement. So let's say we have this little shape here to represent the rocket facing to the right. What we want to do is we want to be able to move forward in the direction that we are facing, and then the left and right keys should rotate the rocket around depending on which way you press. Now, the thing is, we don't want to move the rocket forward and then have it immediately stop. So we're going to need some sort of max speed variable to represent the speed that we want to go to at maximum. And we are going to want some sort of speed value so we can determine what speed we are currently at. So now what we're going to do is we're going to go in here and we're going to change this code to get it to work with our boosting momentum-based movement in mind. So we're going to create what is called a constant. So you define a constant with const. It's just like a variable, but you just do const instead of var. And constants are just variables that never change. And so we're going to do max speed, and we're going to make this a float, actually. And we're going to set this equal to 200.0. And we're actually going to go to our speed, and we're going to change this to a float as well. And you'll see shortly why we're doing that. Then we're going to have a const variable called acceleration, and this will be 200 as well. So to get our input in our physics process, we can use a handy function called input.isActionPressed every frame to determine if the button is pressed or not. And we're going to do that with our move up. Now, the issue is we need some way of checking if this is true to do something. And that is called conditional logic. And we just do that by doing if and a colon. And it is just like Python, where it is tab-based. So if input.isActionPressed move up, we are going to move the speed towards the maximum speed by a value of acceleration. And we actually converted these values to floats so that we could use a function called move towards. So we can just go speed is equal to move towards, which is just a function that is based in the main base version of Godot. It is just part of Godot. So you can do move towards, and we can move our speed towards our max speed by a value of acceleration times delta. And what this acceleration value will tell us is basically how long it will take to get to max value. So we're going to do that at 200, and that should work. Let's remove our other input, and let's just kind of test this and see what happens. Nothing. Well, what you'll notice is we're actually not setting our vector anymore. We're not setting our input velocity. So we're doing a vector 2 of 0 times speed. So what we're actually going to do is we're going to change this input vector to vector2.right. So it's always to the right direction. So now if we start the scene and we press W, we get it to move towards. But what happens if we let go? It just goes forever. So now we need to check to make sure it goes back to 0. So we're going to have an else, and we're going to do the exact same thing, but instead of moving to our max speed, we're going to move to 0.0. And now what you'll notice is we move forward, and we release, and we slow down. Now what we can do is we can actually make it so that the deceleration is a different value from acceleration. So the acceleration can be fast, and the deceleration can be really slow. All we have to do is create a new variable. deceleration. Let's make it 100, so half the amount of time. And let's make our acceleration 400. And our max speed 300. A little bit of balancing there. All we have to do is just replace right here this to our deceleration. And in theory, we should get a very fast start. And if we release, it gradually slows down. Now, we have a little issue here. The rocket's not faced in the right direction. So how do we actually go about fixing that? We want to make sure that all of these things that our children here are facing in the right direction. So we can just rotate all of these. And so to rotate multiple things, to edit properties of multiple things, you can just click one thing, hold down Shift, and click the bottom. You have all these selected, and we're actually going to edit a property of all of these nodes. So we're going to go to Transform, and we're going to rotate 90 degrees. And you'll notice this doesn't affect these positions, so we just need to reposition these collision shapes so that they're in the right place. And now, if we actually go back to our game level, we can test it with the player being over here on the left. If we do this, we go forward and we release, and it slows down gradually. That's exactly what we want. The next logical step is getting rotation to work. So what we need to do is we need to rotate the whole thing based off of if we're doing left or right movement. So what we're going to do is we're going to create a rotation speed. So we're going to do rotation speed is going to be a float. And then we're going to duplicate these acceleration and deceleration values. And we're going to go call these rotate acceleration and rotate deceleration. And we're going to make these a lot tighter. We'll make these like 400 and 400. And we'll do the same thing with the max speed. We will have a max rotate speed as well. We're going to do these as 50, 100, 100. We can always balance this later. So with this, we just do a similar thing. So we're actually going to utilize our input mapping to determine which way we actually want to rotate. And to do that, we need some way to store which direction we're rotating. So we're actually going to do rotate direction as an int, and this is going to be equal to 0. What we can do is we can use the input actions like we used before, for input strength. We can do rotate direction is going to be equal to input.get action strength of the right minus the action strength of the left. So we have a rotate direction. We can now rotate this whole thing. Well, we can move towards this. So we can check if the rotate direction is not equal to 0. Otherwise, we do other code. So if it's not equal to 0, meaning we're rotating in one direction, we want to actually lerp. We want to move this rotate speed to where we want to go. So we're going to do rotate speed. We're going to do exactly like we did down here with move towards. So we're going to do rotation speed is equal to move toward from the rotation speed to the rotation direction times the max rotate speed by a factor of rotate acceleration times delta. So what we're doing here is we're taking the rotation speed and moving it in towards whatever our rotate direction, whether it's 1 or -1, times the max rotate speed, and then we're rotating it by the acceleration. We're then going to copy this entire thing, and we're going to replace this middle thing with 0, and we're going to set this last thing to rotate deceleration. Now, if we test this, we can see if it works. And we will test this in the game level. Well, it does not appear to work. And that's because we're not actually setting the property of the node itself. So this is what's nice about Godot. All those properties I showed you of nodes, all these properties, these can all be edited via scripting. So I can go in here, and you'll notice there's this transform called rotation. And I could just access it by going rotation. I'm going to set rotation plus equals to rotation speed. And we're going to multiply that times delta. And what we should get if we go to the game level is we get rotating. It is quite fast. So let's adjust our values now. Let's make the max rotate speed 1. And let's make our rotate acceleration and deceleration 1 as well. We should get a nice little drift. Maybe we'll bump up the rotation speed a little bit. And we'll probably bump up the acceleration as well. And deceleration. So there we go. That creates a fairly balanced movement of rotation. Now, if we try to go forward, you'll notice we're still just going to the right. We are not going to the direction we're actually facing. And that's because we're still using vector2.right. So now we need to change this to the direction we're rotating. Now, there are several ways we can go about doing this, but personally, I am actually going to go about it using trigonometry. So what we can do is we can actually set our input velocity equal to the vector 2 of cosine of the rotation and sine of the rotation. And that alone, in theory, should actually move our rocket based off of where we're facing. And this will work for now. This is not the most complex thing, not the most robust thing, but it is a nice little basic input motion for a rocket, and it feels pretty good. It feels more like car movement, but I don't want to go too crazy into the actual like creation of a game. I just more so want to touch on how to actually go about creating something in Godot itself. So now that we have that rocket movement working, we can actually move on to the next step in the process.